Hello, this is Sadashiv Fadnis, Product Marketing Manager for Rubidium signal generators here at Anritsu. In this video, I'll be explaining various trigger mechanisms available in Rubidium's pulse train option. If you would like to learn more about Rubidium's pulse train option itself, please look at video titled Generating Pulse Train, option 25, published previously. Wide variety of trigger mechanisms available in Rubidium's pulse train option enable users to generate long periodic and non-periodic pulse patterns. Such pulse patterns are very useful for many measurement applications, including testing radar warning receivers. This video has 4 parts. Part 1 explains the setup and the free-running trigger mode. The second part explains single step and single sweep trigger modes. Part 3 explains breakpoint and multiple sweep trigger modes. Part 4, the concluding part, explains various trigger sources and how to combine them with trigger modes to generate periodic and non-periodic pulse patterns. I will use this setup to generate a pulse train and show how it can be combined with various trigger mechanisms. In this setup, RF output of Rubidium signal generator is connected to MS2090A Anritsu handheld spectrum analyzer. I have also connected Rubidium's pulse sync output to external sweep trigger input of MS2090A. Rubidium's pulse sync output generates a TTL sync at the start of each pulse period. Ethernet ports of Rubidium and MS2090A are connected to my laptop through an Ethernet switch. This enables me to run remote GUIs for each instrument on the laptop so that I can control, configure Rubidium and observe its RF output spectrum on the laptop. Here is my laptop screen with the two remote GUIs. This is Rubidium remote GUI. It pretty much mirrors the GUI on the front panel of Rubidium. This is MS2090A remote GUI. It also mirrors the GUI on MS2090 instrument. With these two GUIs, we have full capability to configure settings on both the instruments. Back to Rubidium GUI, we'll start with setting the frequency and the level. Let me set the frequency to 10 gigahertz and level to some larger number like 0 dBm. And now we will go set up our pulse train. So if you go to pulse modulation, if you go to modulation menu and then go to pulse train menu, you will come to the setup screen. So don't do anything on this screen yet. Let's go define our pulse bursts first. And I have defined 3 pulse bursts. The first pulse burst is the one with 200 microseconds high and 200 microseconds low to be repeated 3 times. The second is a very narrow pulse, 20 microseconds high and 100 microseconds low to be repeated 11 times. And the third is 100 microsecond wide but 20 microsecond low to be repeated 3 times. So after defining the 3 pulse bursts, you need to add up all these periods multiplied by each of these repetition numbers to come up with a total PRI period for the pulse train. And the number you come up with when you add all these and multiply with repetition numbers is 2880 microseconds. So we'll make a note of that, 2880 microseconds. And then from here we will go to the trigger mechanisms. So let's look at what trigger mechanisms are available. So there are two trigger settings that you can do. One is called a trigger mode, and the other one is called a trigger source. So let's look at the source first. Uh, Trigger source, when you choose single, it uses internal trigger mechanism, and the others are self-explanatory. External is external trigger signal, and external gate is gated external trigger signal, and timer, and I'll talk about this timer source a little bit later. But these are the four triggers source mechanisms. And then we have a trigger mode. There are 4 or 5 trigger modes. The first one is free running, and then single step, single sweep, and then breakpoint and multiple sweep. And we'll explore each one of them subsequently. But let me start with free running mode. Free running mode is essentially uses internal clock continuously to generate the pulse pattern, and this is the most common mode that people use, which continuously generates a pulse pattern. So we are going to choose that, and then we are going to go to the setup. And then, as I mentioned, the PRI period that I came up with by adding all the periods of the pulse burst was 2880 microseconds. So as long as you set this PRI number something larger than that, something larger than 2880, and then it should be good. That's the valid number. So I have set 2890 here. Let's go with that, and then enable the pulse train. Now let's go look at the spectrum. You can see the RF being modulated. Now, in order to see what kind of pulse pattern is being modulated on this RF, we can make use of a spectrum analyzer zero span, so that it essentially decodes the envelope of this RF, and we can see our pulse pattern being generated. So let me go and make this 0, and that's our pulse pattern. And we can go back and look at what pulse bursts we had defined, and then see if we can correlate. So you have the first pulse burst, which is 50% duty cycle, 200 microseconds on and off period, to be repeated 3 times, and that's our first pulse burst. Then your second pulse burst with a very narrow high and a much larger low, to be repeated 11 times, and there you go. You have 11 of those bursts here. And then the last burst, which is 100 microseconds high and 20 microseconds low, and you have 3 of those. So you have the first pulse burst with 3 pulses, 50% duty cycle. Then you have the second burst with 11 narrow pulses, and you have the third burst with 3 wide pulses again. So that's our 3 pulse bursts, and then the same repeated again, because we chose the free running mode and trigger source as internal. So internally it is going to generate, it is going to trigger this pulse pattern again and again, right? So this is our first trigger mechanism, which is free running, and with this mechanism you can generate cyclical pulse patterns. You can generate periodic pulse patterns.